For years, actually my entire career, I have been promoting food as medicine. Today, I am beyond proud to announce that food actually is medicine. In fact, our entire Plant Strong food line has just undergone a rigorous review process, and because of our nutritional integrity and everything that we stand for, we now qualify for HSA, FSA reimbursement. What exactly does this mean? This means that the pre-tax dollars that you save into these health savings accounts can be redeemed for our food line when you purchase directly from our website. If you have an HSA, FSA debit card, you can complete a quick questionnaire and then use that debit card for making your purchase. If you don't happen to have a debit card for your HSA, FSA, you can still complete the questionnaire and then file for 100% reimbursement. We are so proud of this distinction and hope that you take advantage of the roughly 30% savings that you'll net when you use your health savings account to purchase Plant Strong foods. And then you can enjoy all of our foods in support of your health goals. It is a new day for Plant Strong and for everyone who wants to follow a whole food, plant-based lifestyle to improve their health. Simply visit plantstrongfoods.com and go to any product page to learn more about this incredible benefit. Thanks. I'm Rip Esselstyn, and welcome to the Plant Strong podcast. The mission at Plant Strong is to further the advancement of all things within the plant-based movement. We advocate for the scientifically proven benefits of plant-based living and envision a world that universally understands, promotes, and prescribes plants as a solution to empowering your health, enhancing your performance, restoring the environment, and becoming better guardians to the animals we share this planet with. We welcome you wherever you are on your Plant Strong journey, and I hope that you enjoy the show. Hey everyone, welcome to the Plant Strong podcast. I hope that you all had a fantastic Thanksgiving with family and friends, and that you're getting back into the swing of things as we move through our week. I want you to know how much I appreciate all of you, how grateful I am for you taking the time to listen to the podcast and to enhance and hone in on your Plant Strong lifestyle. We hear the phrase metabolic health get tossed around a bit, but do we really know what that means? And more importantly, how much do we actually understand regarding the massive impact that metabolic health has on literally every system of our bodies? Today, I want to explore that line of thinking with Dr. Casey Means. She was trained as an ear, nose, throat surgeon, but in recent years, she has become a self-proclaimed food as medicine evangelist. Why would she make such a drastic change in a successful budding career? Well, as you're going to hear today, Casey, like most doctors, pursued medicine in order to help people, but started realizing that most illnesses, even those that she was treating as an ear, nose, throat surgeon, came back to a person's levels of inflammation and poor metabolic health. Now she's on a mission to create a healthier world through her work and her company, Levels Health, a continuous glucose monitor company. Today, we're going to focus our conversation on exactly what metabolic health really means, as well as the 9 elements of metabolic health. Casey also discusses the importance of metabolic health as it relates to exercise and even sexual health. I was super impressed by her wealth of knowledge, and I think that you will too. So let's get into it with Dr. Casey Means. Casey, welcome to the show.
Thank you so much for having me.
My pleasure. So Casey, how in the world did you get the name Casey as a first name? I have one of my best friends in the whole wide world has a daughter, and her first name is Casey, but you don't hear of a lot of women whose first names are Casey.
I love that question. And I am so embarrassed to say that there is like not a great reason for this. My
Oh,
parents truly just loved the name. I will say I was originally named Paula Casey Means. So my first name is actually Paula, which was after St. Paul, who was a saint that my parents liked quite a bit, and his message. And when I graduated from medical school, I actually legally dropped Paula from my name because that was the time when you're getting licensed and you're getting your white coats embroidered and all this stuff. And everything was going to be Paula, which I knew would be confusing for the rest of my life with the first name Paula, but I went by Casey. So now I have no middle name and I'm just Casey Means.
wow, nice and simple.
Yes.
Well, good move. It worked
Yeah.
for you.
Yeah.
So tell me, you're a doctor and you're working to create a healthier world. That's like something you're really after. You're doing some really incredible things. Tell me this: what kind of doctor are you, and why did you decide to go into medicine?
Mm. Well, I trained as an ear, nose, and throat surgeon. So head and neck surgery, ENT, otolaryngology, they are all the all the same field. And I was so attracted to that field in medical school because so much of the way we interact with the world is through our head and neck. It's all our senses, and people can really lose faculty of these different senses: smell, taste, voice, hearing. And I wanted to be a part of helping people, um, maintain and preserve their senses and really be able to engage with the world as deeply as possible. And not just those patient stories in medical school of people who had to have their parts of their larynx and their voice box removed, or lost their hearing for all sorts of different reasons, or couldn't breathe through their nose. Like, all of these things just really touched me on a deep level. And I felt really inspired to work on this amazing,
Hmm.
complex part of the body. I went into ENT. I went through 4 years of surgical residency, and it was very interesting because what I found, and it's funny, as a medical student, you pick a specialty to go into without you're like 24 years old, and you're picking this thing that you're going to do for the rest of your
Yeah.
life. And it's interesting, this sort of disconnect between what you think you're going into and then what actually really is the reality. And one of the things that was so interesting to me when I went into ENT, and I'm 4 years into my surgical training, is that I realized that almost every single condition that I was treating as an ear, nose, and throat doctor was inflammatory in nature. Like, the suffix in medicine for inflammation is itis. And
Hmm.
so what I kind of woke up and I was like, everything I'm treating is an itis. It's sinusitis, laryngitis, tracheitis, thyroiditis, cellulitis, otitis, all these different itises. And fundamentally, inflammation, it's the upregulation of the immune system. It's inflammatory cells in tissues for a long period of time, sort of spewing out all these
Hmm.
inflammatory chemicals that creates that swelling and that redness that we associate with inflammation. And when this is happening in these small areas in the head and neck, like the voice box or the trachea or the ear or the sinuses, it becomes very symptomatic and problematic. So a lot of what we do as ENT doctors is we either use steroids to decrease that chronic inflammation, or with surgery, we punch holes in things like the
Hmm.
eardrum or the sinus wall, or we dilate things that are swollen and closed, and we basically create more space that the inflammation has essentially impinged on. So that was really interesting. And I thought, I'm basically an inflammation doctor in many ways as an ear, nose, and throat doctor. And it really struck me, and this hit like a ton of bricks for me 4 years into my training, that I was not clear what was actually causing that inflammation. Like, it's not normal for the defense system of the body to be chronically activated.
Hmm.
That's what's leading to these symptoms. And it's like that it's essentially like a war is being fought all the time, but instead of ever asking what's causing the war, we just are constantly going to battle with it with steroids and surgery. And it really struck me, this is ultimately a cellular physiologic problem that we're basically approaching with this like heavy hammer of drugs or with plumbing, with
Mm,
surgery.
mm.
That doesn't actually do anything to affect the what might be causing those cells to be so activated and sort of waging this war inside the body. So that actually sent me, that was 6 years ago or so. And that sent me on a totally different trajectory that has led me actually to no longer be a surgeon anymore and to be a company founder and to be really a food as medicine evangelist. Because what I discovered in that journey of asking why all the inflammation, why all this threat signal in the American body, a lot of it leads directly back to food and the
Yeah.
really sort of the frankenfood, this non-food sort of like chemical substances that make up the majority of the American standard American diet today. You know, almost 70% of the foods in our grocery stores are ultra processed packaged foods that were made in factories so far from the actual soil and the ground that our body's expecting. And so that was kind of the journey of from a ear, nose, and throat doctor to really a food as medicine evangelist, and really believing that if we can fix our diets, we really reduce that threat signal in the body. You know, we eat almost 70 metric tons of food in our lifetime. And you can
Yeah.
imagine if 70% of that is sort of these artificial, totally altered substances that our bodies never really evolved to eat, these proteins that are kind of novel and different. Of course, that's going to be a huge threat signal for the body. So, how do we get back more towards beautiful, nutrient rich, whole foods that our body is expecting, that it wants, that allow it to be in a safer situation and ultimately reduce some of that chronic inflammation that's leading to not only ear, nose, and throat issues, but so many of the other chronic diseases that are killing Americans today.
Well, that's fascinating how you went from ear, nose, throat to doing what you are to now, and how those docs kind of connected for you. And obviously, you are insanely passionate about what you're doing now. It's wonderful. I want to go a little deeper. So you mentioned some things. You mentioned this, the cells a lot, and how almost 70% of the foods in the grocery store are coming from a factory and the soil. Um, you you're all about metabolic dysfunction, right? And trying to, and conversely, trying to get people to have metabolic health.
Right.
And I think that it was, I think you said that what, 93% of Americans have metabolic issues.
Yeah.
And you want to expand on that?
Yeah, absolutely. I mean, and it's not coming from me, it's coming from the research literature. Recent research as recently as last year, looking at large populations of Americans shows that 93% of people in this particular study um, have at least one biomarker of metabolic dysfunction. And this was actually a follow-up to a study that was done more like 4 years ago from UNC that showed that 88% of American adults have at least one biomarker of metabolic dysfunction. So it had between these two studies over a couple years and different populations, so hard to exactly know, but looks like it's getting worse essentially every year. This
Sure.
parallels with other statistics we're seeing, which is that life expectancy is also going down in the US over the past 4 years, the first sustained drop in life expectancy um, in well over a century. And so
Hmm.
there's really, I mean, ultra alarming trends happening with essentially our core cellular processes that are just absolutely crippling the American population and our ability to have long healthy lives and to reach our highest purpose in this lifetime, because in many ways our cells, there is evidence that our cells are breaking under the stress of the modern industrialized environment that we're living in, that essentially our cells aren't prepared to
Yeah.
handle. And what we see is that um the forces that we're living in, sort of, we're bodies of 37 plus trillion cells living in an environment, and that environment is really synergistically hurting the parts of our cells that do our metabolic processes, our mitochondria, in particular. And this leads to metabolism is how we make food, how we make cellular energy from food energy. It's a conversion process of taking all this food energy and converting it into an energy that our cells can use. And, our lives are just simply the bubbling up of all the chemical reactions happening in those 37 plus trillion cells. And all of those chemical reactions require cellular energy to occur. So if we have a problem converting food energy to cellular energy, we get essentially cells that are malfunctioning little machines. And then what you end up getting is all sorts of different symptoms and diseases that, if you trace it back to the inside of the cell, really fundamentally are about an underpowered cell, a cell that is sort of breaking under the weight of the environment. And so that term metabolic dysfunction, what it might bring up for people is like, okay, that sounds like, I feel like I've heard that in relation to like obesity or type 2 diabetes. Like, a lot of people can put those kind of words together. But what is under recognized in our country, and definitely in the medical field, is that metabolic dysfunction is actually driving almost every leading cause of death in the United States, and so many of the other symptoms that we deal with day to day. An underpowered cell, a metabolic dysfunctional cell in any part of the body, can lead to symptoms. So in the liver, that can look like fatty liver disease. In the brain, that can look like Alzheimer's, dementia, depression, anxiety, fibromyalgia, migraine. All conditions we know are associated with metabolic dysfunction. In the vascular system, it can look like retinopathy, erectile dysfunction, stroke, heart disease, all these conditions we know associated with the blood vessel lining being problematic. In the ovary, it can look like polycystic ovarian syndrome, which is the leading cause of infertility in the United States, but it's fundamentally actually a metabolic problem in the ovarian cells. So take any part of the body, and when you zoom in, take any part of the body and look at the symptoms that arise there, and you would probably think, oh, these are all different diseases. Arthritis is different than Alzheimer's, and is different than cancer, is different than heart disease. And that's the way we thought for many years, because we didn't have the tools to really understand the core physiology. So we were describing these diseases based on their symptoms, which look different. But if you really zoom in and look at the inside of the cell, a lot of them are rooted in mitochondrial dysfunction, the cells filling with toxic fats and blocking the metabolic processes that let cells run properly. And that's ultimately metabolic dysfunction. And the way that shows up in our lab work is various biomarkers that we associate with metabolic dysfunction. This could be like triglyceride levels, fasting glucose levels, HDL cholesterol levels, blood pressure. And those are the biomarkers that get studied in these large studies that we were talking about earlier, that suggest that if you look at these metabolic associated biomarkers, waist to hip circumference is another one, we see, waist to hip ratio.
Isn't that defined as metabolic syndrome? Those things that you're talking about?
When you have 3 of 5 of them, it's defined as metabolic syndrome. And so these are sort of like these biomarkers that can give us a little clue about what's going on in the cell. When you take all of them and you study the population, 93% of the population has at least one that is not in the normal range off medication. So that's pretty alarming. And my real mission as a doctor on this planet is to help bring a metabolic framework to our healthcare system, because the reality is we're spending $4.1 trillion on healthcare in the United States. It's over 20% of the largest GDP of any country in the history of the world. And yet, the more we spend, the worse the health outcomes are getting. It's literally the definition of unsustainability. The more money we throw at the problem, the worse the outcomes are getting. And I believe that's because we're actually focusing on the wrong problem. We're focusing on a reactive approach, a symptoms-based approach to the downstream manifestation of these diseases, rather than a root cause approach that truly addresses the disturbed physiology that's happening, and that is fundamentally driven by our diet and lifestyle, which, of course, I know you've talked to many guests about this, Cyrus Khambatta, is not taught in medical school or in our PhD programs. And it's really a reframe, because if you throw money at the wrong problem, of course, it's not going to get better. So we need to be focusing on the right issues.
Yeah. Well, I'd love to dive into some of the elements that that you say can help with people's metabolic health. Before we do, you also say that like the elephant in the room
Mhm.
in modern America healthcare right now is that we have agency over our own fate. And would you say that most people are, for whatever reason, not aware of that?
I think
That
that's right. I think they aren't. I think they aren't. I mean, there are still doctors that I know who are treating chronic illnesses, even treating chronic illnesses related to the GI tract, the part of the body that processes food,
yeah,
and are saying that food has nothing to do with the diseases, or that it's incremental, or that, oh, take this medication, I don't know. Like, there's just this complete blind spot in most of healthcare, to basically any of the levers that we can pull that can help us pull ourselves out of our symptoms and diseases. And this is due to so many things. One of the big ones being that physicians are literally not taught nutrition in medical school, even though poor diet is related to 9 of the 10 leading causes of death in the United States. So it's completely like a bizarro world that we're living in.
yeah.
And so there's just what's interesting is that patients actually in many ways do what doctors say.
Mhm.
When the Surgeon General said we need to decrease smoking, smoking went down. When we said, eat 6 to 11 servings of grains and pastas per day, like those foods went up as a proportion of the American diet. If every doctor in America was saying our chronic disease epidemic is fundamentally rooted in food and we need to be eating better as a country, I believe that people would do it. What's the problem is that they're not saying that in unison. There's still so much uncertainty. There's so much nutritional dogma, warring going on, and so people are confused. So I think a universal message from physicians, researchers, coaches, trainers, just saying like, actually, we all need to focus on food. I think people would focus on food, but right now there's just still so much undermining of that message. And I think it's fundamentally rooted in the fact that we're not educated on it. And every doctor I know who is practicing food as medicine in their practice has had to do it outside of their
Mm.
traditional training. They've had to pursue additional independent training to gain that skill set. So it ends up being like a labor of love, essentially like pro bono work to become nutritionally literate. Of course, those are the doctors, I think about like Lori Marbus,
Yeah.
who like end up seeing the most profound disease reversal in their patients. And actually physician attrition, physicians basically just quitting medicine is basically like a public health crisis. So many doctors are
Mm.
retiring early. And I think a lot of it has to do with the fact that there's a spiritual crisis in medicine where we're working so much, but our patients aren't getting better. And so one of the things I really think about is that like if doctors did have more nutritional literacy, it actually could really help them sustain the enjoyment of their practice because they would see such different profound outcomes in their patients that would be so heartening. And I think that would really help with the burnout that we're seeing in medicine. So it's very multidimensional, but
Yeah, yeah, absolutely. I mean, I would imagine that most physicians go into medicine because they want to help people, right?
yeah.
And you get caught in this system, and before you know it, you're kind of pushing the pills and doing the procedures, and you're not getting, as we've been talking about here, to the root causation of the problem. I saw a cartoon this morning, and it was two people behind a desk, and one's sign said, pills and procedures. The other one said, lifestyle medicine. And the one with pills and procedures was literally the line of people was out the door and around the building, and lifestyle medicine, there wasn't one person there.
I've seen that meme, and I
Yeah,
have to tell you, I actually hate that meme. And let
yeah,
me tell you why.
please.
Because it puts the response, it's basically reinforces what I think is such a damaging idea, which is that people are lazy and people want the easy solution. And I don't think that's true. I talk to
Mm,
15 levels members a week, but they're not my patients, but they're people who are striving for better health. And the dominant message I hear is that they are desperate to do whatever they can do to be healthy, but they are so confused and the system is not helping them. We have trained patients because of the backwards incentives and education of American doctors. We have trained patients to believe that that is the answer, and therefore they are listening and they are doing it. But I don't think it's fundamentally an issue with that people don't want to do the work. I think it's that we have literally on every level of society, from advertising on our TV shows to what doctors are telling them in the office, you know, to social media. It's basically told them that that is the right answer. But I believe that people, by and large, all walks of life, they're not trying to systemically kill themselves and be lazy. I think the system has been designed to make them think that is the right answer, and they're following suit. And that is because of, you know, trillions of dollars of interest and incentives across processed food, pharma, healthcare, industrial agriculture, even the chemical industry, which all want people to believe that the simple solution is the one that's better, even though it's not. So that's what bothers me about that meme, is that people, I do not believe, are actually just like looking to have the easy way out. I think we have literally trained them to believe that is what is the better answer. And we need to empower people to go to the other line. And I think they will.
Mm-hmm. Well, just to get back, and then we'll close this conversation on this. But if you knew how many times I talk to people that come to our events or our medical immersion programs, and they say that their doctor basically is like, yeah, but you won't stick with it or you won't do it. So they're not being empowered by their physicians, or they're saying, yeah, but you know what, most people can't do it. So they're not giving their patients the benefit of the doubt, which is infuriating to me. And then when they do it, because they've read the books and they believe in themselves and in this lifestyle, then they go back. The physician, instead of saying, tell me everything you did, I want to write it down and I want to be able to give this to the next person. It's more like, you just keep doing what you're doing, but I don't really need to hear about it. I mean, doesn't
Or like,
that,
wow, this is such a shock. Like you know,
yeah,
like this is like really surprised by it. Whereas like people like, you know, in our community who are practicing this, like it's not shocking at all. You know, it's like, of course this happens, you know, and so I've seen that a lot as well. I agree.
yeah,
It's
yeah.
disempowering. Yeah.
Okay, let's talk. So you have 9 elements of metabolic health. And if you don't mind, I'd love to, I'll throw them out to you. I'll tee them up to you.
Yeah.
All right. So the first one that you talk about is micronutrients. So why are micronutrients important for metabolic health?
Oh my gosh, I love this question. So micronutrients are essentially like the vitamins, minerals, antioxidants, like the small little molecules that we get from our food, that are really important for like several elements of our biology. Like you have to think of the body, it's basically like a big chemistry set. And like I said earlier, like we are essentially the product of trillions upon trillions upon trillions of chemical reactions every single second. And a lot of what is happening in those chemical reactions is transformations that require these micronutrients for those things to work properly. So these are things like you think about like zinc, magnesium, selenium, B vitamins. They often act as cofactors for metabolic processes, meaning that like if you're trying to in the body transform substance A to substance B, often that will happen with what's called an enzyme, which is like a protein that converts substance A to substance B in some chemical reaction. Sometimes that enzyme, which you can think of like as a little protein machine, requires a couple little micronutrients to bind to it to act as almost like locks and keys to
Mm,
unlock the ability of that thing to work. So you essentially want your body to be filled with a lot of these micronutrients in the right levels such that all these chemical reactions can happen properly. Um, and so, unfortunately, in our largely ultra processed standard American diet, so many of the foods have been so stripped and transformed and ground down from when they came out of the soil to when they actually make it to your food, that so many of these micronutrients are just being lost. Our food is like devoid of the richness, the chemical richness that was in it when it came out of the soil. And a second problem is that the soil now in the United States has become depleted in many ways of life. And so the food itself actually isn't being sort of injected with the micronutrients it needs as it's growing because the soil is essentially depleted. So if the soil is depleted of micronutrients in life, the food is going to be depleted. And this is largely because of our industrial agriculture culture where we are spraying our crops with pesticides. We're using really aggressive agriculture techniques like tilling. We're not using cover crops in between harvests, which basically inject the soil with more nutrition.
Mm.
We've disaggregated growing plants from the pasturing of ruminant animals, which is basically animals walking around on the farms and pooping and peeing and agitating the soil with their hooves, which brings through that the nitrogen in the urine and the bacteria in the feces, like actually builds a thriving ecosystem in the soil. All of this has essentially led to food that is objectively more micronutrient depleted, and that's been studied. And so what happens is then you have this body that's eating all this stuff that looks like food, but the molecular composition of the food is actually sort of less than what it could be if these things were different. And so we really, a big focus for me in helping people optimize metabolic health is get the most bang for your buck with each bite that you're eating. And that usually means moving from processed foods to whole foods. And then secondarily, moving from foods that are conventionally grown to more foods that are regeneratively grown or organically grown. Organic is great because the food is going to have had less of that exposure to the pesticides that can create more lifeless soil. Regenerative is actually better because that's vegetables that are grown on a farm that has ruminant animals on it generally. So the soil is going to be as rich as possible and as filled with life as possible. So that's kind of the skinny on micronutrients. They're key factors for metabolic processes. The second thing I would also just mention about micronutrients is that many of the micronutrients, these vitamins, minerals, cofactors, many of them are antioxidants or polyphenols. So these types of small molecules that actually have a different function in the body. The antioxidants and many of these like overlap in categories. So there are some micronutrients that are both cofactors for certain reactions, but they're also an antioxidant. And all an antioxidant means is that it has the chemical structure to basically take on an electron from something else in the body or the cell, an unpaired electron that could be damaging if it's not neutralized. An electron is, negagatively charged and if it's unpaired, it wants to go around the cell and bind with things. And if it binds to the wrong thing, it can cause damage to it. So an antioxidant is floating around to bind that electron and neutralize it so it doesn't cause damage in the cell. So these micronutrients can act as antioxidants. Which is important. Some of them are polyphenols, which are often the plant chemicals that give plants their beautiful color. And polyphenols are fascinating for so many reasons. I think about them as like little molecular medicines. One of the big purposes of them is they're actually consumed by our microbiome and transformed into healthful postbiotic chemicals, many of which are metabolic regulators. And so polyphenols are important. So these beautiful small molecules in plants that give them color. And then the last thing I'll mention is that some of these micronutrients, like selenium, for instance, they actually are critical, when you're making a protein in the body, when you're expressing the genes and then turning that gene into a protein. Sometimes you need to the cell is essentially, as it's making a protein, it's grabbing all these things from the cell to build that protein. And sometimes it needs to grab certain micronutrients like selenium. There's a class of proteins in the body called selenoproteins, which need selenium as part of the manufacturing process. And part of that class of proteins are many of the antioxidants that our bodies make. So we eat antioxidants and we make antioxidants. We can do both of those. We want to do both. But to make key antioxidant proteins like glutathione and other things like that, you actually need to be able to pull these micronutrients in the manufacturing of those things. So several different reasons why we want to basically think of eating I think of grocery shopping as like a micronutrient and antioxidant hunt, because it's not that we're just buying food, we're buying molecules and we want to get maximal positive molecules for the body that we know are going to help our biology. So So that's kind of the skinny on micronutrients.
Wow.
I can go
So,
quicker for the other 8,
mm,
but I just could talk about micronutrients all day.
yeah.
So
But tell me this. So for somebody that didn't study nutrition in medical school, you obviously have studied it and studied it extensively. Is that just from diving into books and educating yourself, or where'd you get your education?
great question. So I actually was so lucky when I was an undergraduate at Stanford. It was right during like the Human Genome Project, and also during when 23andMe was starting in Silicon Valley. And so I got very interested in genetics, and I got so lucky. One of the classes I took was about Nutrigenomics, which is basically how the food goes into our body and changes our gene expression. I had gone through high school biology thinking our genes are our destiny. And what I realized is that it's actually the interaction between food and our genes that leads to the expression of our reality. And, two easy examples of this that I learned about at like age 18 that would then put me on a particular track forever of like really believing in the power of food was curcumin from turmeric
Yeah.
and isothiocyanates from cruciferous vegetables. So with turmeric, everyone says, oh, it's so anti-inflammatory, and people in India eat all this turmeric. And until recently, there was very little reported Alzheimer's disease. What's that relationship? And basically in turmeric, there's a substance called curcumin, which actually literally interacts inside the cell with this genetic pathway called NF kappa B, which is our master inflammatory genetic pathway in the body, and turns down the expression of the NF kappa B pathway through
Oh,
like very clear molecular interactions. So you can eat this thing and change your propensity to have a pro-inflammatory state in the body. And like we talked about earlier, most diseases affecting
yeah.
Americans today have this sort of inflammatory metabolic underpinning. Um, the second one was isothiocyanates from cruciferous vegetables. And those are a chemical in cruciferous vegetables. And amazingly, and Michael Greger talks about this a lot in How Not to Die. You chop the cruciferous vegetables and you actually want to let them sit out for like
Isn't it
45.
like, yeah.
Yeah, like you need to let them basically activate with air. You crush the tissue with the knife, you let them sit out to air, and a chemical reaction happens in the plant, which activates these chemicals
Yeah.
and makes them more heat stable. And then they go into your body and they change the expression of this pathway called NRF2, which it actually upregulates NRF2. And that's one of the genetic pathways that causes you to make more antioxidants in the body, which then quell those unpaired electrons and keep a more sort of safety environment in the cell. So I learned these things at a young age, and like you can't put that genie back in the bottle. Like
Mhm.
it's like anyone who says like, oh, people just they're on a track and it's the family history and da da da. It's like, wait, but I had learned that there's something else here. So that was kind of what kicked it off. And then frankly, it was just a series of disappointments in my education after that, where it's like, why aren't we talking about this? I
Mm.
know there's power here, but like I go through 4 years of medical school, we're not talking about food. I go through 4 years of surgical residency, we're not talking about food. And I'm like, where did this go? Like what happened?
And did
I
you
was learning.
ever did you ever ask
Oh yeah.
your professors or chief interns or whatever?
Oh yeah. Oh yeah. I got a reputation, and I'm like, and the way that it works, because our healthcare system is so biased towards, you know, interventions, and we're so incentivized to be more focused on medications and surgery, is I got a lot of really patronizing replies like, you didn't become a surgeon to basically be a nutritionist,
Mm.
something like that. And um I'll never forget, I was reading a lot of Dean Ornish's work when I was in the surgical world. I was starting to kind of dive in, and I remember obviously reading about his incredible heart disease reversal program. And I had never learned in 4 years of Stanford Medical School that you could reverse
Mm.
heart plaques, right? Like we all thought, oh, once they're there, they're there. And then all you can do is kind of like try and make it slow down. But he showed with his groundbreaking research that you can actually reverse heart plaques. So I'm looking at this, and I'm as an intern, a first year resident, you do like cardiac surgery rotations, and it's, triple bypasses and these cracking the chest open to kind of like redo the plumbing of the heart vasculature for heart disease. It's stents, it's things like that. And I'm thinking, here we have nutrition can reverse heart disease. And heart surgery does not reverse heart disease. It just creates a new pathway for blood to flow. So why do we think that the nutrition route is literally wimpy and the heart surgeon is a hero? And no shade on the heart surgeon. Like, that's great that we can do that. But like, why isn't it flip-flop that the nutritionist is the hero? And we would try and avoid the heart surgeon ever getting that place ever. And so I was talking about these concepts, like, and what happened was when I went into residency as a surgeon, I kind of felt like I wanted to be a hero. And over time, I started really feeling that sense of weight of like, I don't feel like a hero. I feel like a plumber. And how do I actually reverse the physiology? And so I would talk about these things, but again, like, I would get some feedback like, that's not evidence-based. This is not in our guidelines. You're not a nutritionist. And you can always pull the evidence-based medicine card, I think, in medicine of like, well, it's not in our guidelines. But what I've come to realize is that our guidelines can be very biased towards pulling in specific research that that promotes our sort of intervention path. And so, I still of course believe in evidence-based medicine, but I think a lot of our research and a lot of our guidelines are compromised because they come through a lens of already not even believing that nutrition should be in it. So of course, those studies don't get as much funding, they don't get brought into conversation. 95% of the people on the USDA food guidelines, this past food guidelines, had conflicts of interest with food companies, and a huge percentage of the NIH's budget comes from industry. So it's a big system. And so people will said to me when I brought this stuff up, it's not in the guidelines. We're not going to do that. You put yourself at risk for practicing differently. Focus on what's in the guidelines. But then you start stepping back and asking, well, why did the guidelines become how they are? And it opens up a real can of worms.
Yeah.
So, yeah.
You were saying, hey, man, the emperor's not wearing any clothes.
Yeah. Yeah.
Yeah. Well, and isn't that funny how, the nutrition is wimpy because it doesn't, and also doesn't make, the doctor or the hospital really any money, right?
That's right. Exactly.
In those procedures. Whew. Yeah.
Yeah.
And so are you still teaching a course at Stanford, Food Design and Technology?
We're not teaching it right now. COVID, one of the silver linings of COVID was that it was all remote. So I was able to teach that course remotely, but now everything's back in person and I live in LA. So I'm not teaching it right now, but it was really a joy to be able to go back to my old stomping grounds almost 10 years later and teach a course all on the things that I basically wasn't taught in school. So that was very exciting and full circle.
Yeah, really. All right, let's keep moving then.
Yeah.
So I'm going to go to number 2 of your 9 elements of metabolic health, and healthy meals. And so the second thing you talk about is fiber. Of course, I've had Dr. Will Bolshewitz on the show twice, but what can you add about fiber regarding, a metabolic, how it helps to let me rephrase that. How it helps to eat a meal that has fiber for your metabolic health.
Yeah, I mean, you've had the GOAT, the greatest of all time, on the podcast talking about this. So there's probably very little that I can add, but I just think it's a public health emergency that we're not eating nearly enough fiber in our diets. It is so interesting to me. We have maybe 100 trillion bacterial cells in our gut, way more bacterial cells than human cells. And what I really love to think about is like, I'm not eating for me. I'm eating for my 100 trillion bacteria in my gut because they are the first pass on the food, right? They see it before my gut lining sees it by and large. And we know so much now about how if our gut is problematic, if our microbiome is more in a dysbiosis state, like not the right sort of
Yeah.
pattern of bacteria, our health will suffer. Like, it is related to cancer. It is related to Alzheimer's. It is related to heart disease. It's related to stroke. It is definitely related to depression and anxiety. You can literally transfer the bacteria from a mouse that has anxiety, uh, transfer their microbiome to a mouse that doesn't have a microbiome, and it will have anxiety. Like,
Mm.
it's just so wild. And so when I'm again with the grocery store, I'm thinking micronutrient hunt, and how do I get the best meal for my microbiome from this grocery store? Um, and the best thing that we can do for them is protect them, so that and feed them. So that would be fiber. And so basically these indigestible carbohydrates and starches that don't necessarily go into our gut lining, but that they transform into healthful postbiotics. So
Mm.
they make them into postbiotic chemicals by transforming them, and then we absorb the postbiotics. So we don't absorb the fiber, we absorb the thing that the fiber was transformed into by the microbiome. And many of those short chain fatty acids like butyrate, they actually go straight into our cells and have an impact on our mitochondrial function.
That is
And there are
crazy. Isn't that
it's
so
so
crazy?
crazy. It's so
Well, and
cool.
it almost goes back to what you were saying earlier with the soil, right? With the ruminants and the urine and the
Yes.
feces, and just how it's all this. You need the diversity of all
Yes.
the different species for optimal health.
Yes. Yes. So I'm thinking, I think the USDA has put out that over 90% of Americans do not get enough fiber,
Mhm.
which is crazy. Imagine you are starving the 100,000 bacteria inside your gut that are sitting there just waiting to produce the stuff you need to be happy, healthy, live a long life, be
Yeah.
fertile, all the things. They just are sitting there like, we want to do this work. Just give us the food, and we just starve them of fiber. And again, that's our ultra processed food that strips off all the fiber. And then the second piece, the second thing that microbiome eat is polyphenols, these plant chemicals that
Mm.
they can convert into healthful chemicals for us. And so you just really want to be thinking about with your fiber, with your diet, maximal polyphenols, and in my mind, maximal fiber. There are indigenous cultures that we've studied in various parts of the world. There are some that eat low fiber, but there are some that eat over 100 grams of fiber a day.
Yeah.
And so I really, the USDA says we need to eat around 30 grams of fiber a day, but I really encourage people to ramp up to 50, 75, which is
Mhm.
not that hard. And the way that I do it is that I just keep fiber sources at the ready so that they can be sprinkled on everything. So if you let's say you're pinched for time and you're not, like, obviously if you can cook your beans and lentils yourself, that's great. But I always have 15 cans of organic BPA free cans, black beans, pinto beans, navy beans, chickpeas. So that's a can of if I a can of beans has, 5 servings, 9 grams of fiber per serving. So, you're looking at like, in the 40s of like fiber. So keep those in the pantry. And I actually on Monday, I'll take like 3 or 4 cans,
Yeah.
rinse them, strain them, dry them, put them in Tupperware so that they're easy. Because
Mm.
then every salad you make, everything you make, you can just dump a half cup of beans on the side. If you have to, so just make it easy for yourself. Then on the counter, have chia seeds, basil seeds, flax seeds, other, pumpkin seeds, just have them out and ready. Cook in the crock pot lentils and put some coconut milk and some tomato paste in there and some curry, just a few easy spices. Do that on Sunday night, have it in the fridge, put it on the side of any meal. So right there with lentils, beans, nuts, seeds, maybe make some chia pudding, for the week. Plus, then you add in whatever other vegetables you're eating just throughout the week, which do have certainly fiber, but not as much of those key fiber foods that I just mentioned. And it's really actually so easy to get 50 plus grams a day, but you got to prepare. You've got to
Mhm.
be thinking about what are my key fiber sources and how do I have them literally accessible for all 3 meals of the day. So,
I figured out the amount of grams that I got just in my breakfast bowl, and it was 41. I
boom.
mean, it's like crazy high. What about, you hear short chain fatty acids a lot with the microbiome and
Yep.
fiber. Can you talk about that for a sec?
Yeah. So basically, short chain fatty acids are a type of postbiotic, meaning, so there's prebiotics, probiotics, and postbiotics. Prebiotics are essentially what the microbiome eats. Probiotics are like the actual bacteria, and postbiotics are the things that the bacteria uh, make by transforming the prebiotics. So
Yeah,
they
yeah,
are metabolites produced by the microbiome in the large intestine through anaerobic fermentation of indigestible polysaccharides like dietary fiber and resistant starch. And there are three main forms of short chain fatty acids, which is acetate, propionate, and butyrate. And this is about 80% of the short chain fatty acids that are produced. And they are absorbed through the intestinal lining and just have like several different effects on our mitochondrial function and our cellular biology.
yeah,
So yeah, so that's kind of the skinny on short chain fatty
yeah.
acids.
I want to get one thing, try and get straight with you, because I've heard different numbers, and you've said it twice or three times. We've got about 37 trillion cells that comprise us,
Yeah.
roughly 37. But I've also heard that we have 10 times the number of, microorganisms in our gut. But that would be like 370 trillion. And
Yeah.
yet I've heard you and other people say about like 100 trillion. So
Yeah.
I know it's not a big deal. I'm just wondering if it's 10 times or it's a 1.5 times. Do we know?
Yeah, I think we have no idea. I think of it as like, I mean, I've heard so many different things, like between 37 trillion and 100 trillion human cells. And then we know we have significantly more microbial cells, also not just on our gut, but of course, all
Right.
over our skin, vagina,
Yep.
butt, mouth, all of it, eyes. And so it's basically the way I think about it. There's a lot more bacterial than human cells, and they're both in the many trillions. So
Yeah, it's a
it's a
lot.
lot. Yeah, it's a
Okay.
lot.
Okay. All right. Let's move on. So
Okay.
number three, I feel like you already addressed. It's antioxidants. You'd lump that in with the micronutrients, right? Your
Yeah,
number one answer. So
absolutely. That's
I think
right.
we're good there. Number four is omega-3 fats.
Yes.
What exactly are you referring to here? The DHA and the EPA, or what exactly?
Yeah, I mean, there's several different types of omega-3 fats, starting with alpha linoleic acid that can get converted to um, EPA and DHA. And this is like, of course, one of those really interesting conversations that becomes very controversial in the plant-based and animal-based community because, of course, animal-based the omega-3 fats that that get incorporated into our cell membranes and that have some of that like anti-inflammatory promoting potential are more the EPA and the DHA. And people say, oh, this is why you need to eat meat and salmon and eggs and things like that, because that's the actual source of those foods. Algae does have EPA and DHA, so that's a great plant-based source of that. But and then the argument often becomes if you're just eating plant-based sources like from chia and flax and other plant-based sources of um upstream omega-3s, it's not an efficient conversion process to the EPA and the DHA. And one of the things I really push back on with that is that um there are ways to make the conversion process more efficient.
Mm,
So one is that it's a multi-series enzymatic conversion from basically plant-based omega-3s to EPA and DHA. And what's really interesting is that those conversions all require those enzymes to have the proper micronutrient levels that are cofactors for those enzymes. And there's a really interesting, fabulous micronutrient test from this company called Genova that basically looks at your EPA, DHA levels, ALA levels, and all your micronutrient levels for those enzymatic processes and can tell you, like, are you low on some of the cofactors that
mm,
allow that conversion to work properly? And some of them are like B vitamins, vitamin C. I think it's like I'll have to look. There's a great image that shows all the cofactors for the different enzymatic reactions. It's like I think manganese is one of them, but basically the bottom line is if we're eating a sort of thoughtless, low micronutrient
mhm.
diet and we're expecting to convert these these omega-3s to the EPA and DHA, we might be like stunting our ability to do that. So we have to think holistically about the biochemistry of the body and optimize and support those processes. And there are people who, I kind of have a foot in both worlds because I was in the plant-based world, and I'm also kind of know like the ketogenic world very well because I focus on metabolic health. And there's obviously a huge camp who believes in more of an animal-based diet. But a lot of people will say like, oh, I was plant-based and I just like felt horrible. And then I ate more omega-3s from animal-based sources and I felt so much better. But my first question would be like, what was your plant-based diet? Like, were you optimizing
Yeah.
these conversion processes to basically make what you are just like, essentially the body is like we are a synthetic machine. We can synthesize things, but we have to be thoughtful about giving the body what it needs to do those synthesis processes.
Mm.
So that's kind of one thought just on like sort of plant-based. Um, and anyways, the key point about the omega-3s is that they're critical for structural biology, as parts of our cell membranes. They're also critical for sort of like the chemical processes in our body. So our immune cells actually come around and they snip fats off of our cell membranes to basically be used as substrates to make various anti-inflammatory or pro-inflammatory chemicals in the body. And so if you have a higher density of omega-3 fats in your cell membrane, just statistically, it's going to be more likely for those immune cells to be snipping off fats that are going to go towards more of the resolving of inflammation processes. So you want to do whatever you can to load the boat in the body with these fats so that just sort of statistically there's more likelihood of kind of moving down the anti-inflammatory pathway. So that I kind of find that I think about that a lot with nutrition is like all these cells are essentially blind. Like they all are blind. Our cells don't have eyes. They don't really have, a lot of it is like, how much are you loading the body with these micronutrients and these omega-3s so that when a cell is kind of blindly looking to grab things, you have given the body enough of that stuff for it to be able to grab the right thing. And I think about that a lot with omega-3s.
What
Load it up.
yeah. And obviously, our audience is primarily whole food plant-based. What do you recommend as the best whole food plant-based sources for omega-3s?
Yeah, I mean, 3 amazing ones are flax seeds, well, 4: flax seeds, chia seeds, basil seeds, hemp seeds in terms of those. I love basil seeds, which are a little harder to find. There's a brand called Zen Basil that
Mhm.
makes them, but they actually have a much higher omega-3 content than chia seeds. And you use them identically to chia seeds. So those are a really nice source. And then I really like different, like algal oil, I'll sometimes take. But those are some, and then hemp seeds I'll use to make like a sort of muesli type thing or like a no oats kind of thing with a bunch of different seeds. But those are my favorites. And I have them all in jars and I just basically sprinkle those things on
Yeah.
on everything. I mean, there's almost nothing that you can't sprinkle some
Yeah.
ground flax or ground chia on.
What about green leafies?
Green, like leafy greens.
Yeah. Yeah.
I mean, certainly I think the omega-3 concentration of those are going to be drastically lower than some of the other things I mentioned.
Yeah.
But certainly like every little bit counts.
Yeah. Okay, let's move on. So, your next on the list is fermented foods.
Yeah.
You're a fan of fermented foods. I don't eat enough fermented foods in my
Ooh.
life.
Okay.
Yeah. I mean, I do the tempeh, but that's about it really.
Interesting. And is that because you don't like the flavor
I'm
or
typically not a fan of like sauerkraut and stuff that's fermented.
that
Kimchi, yes, but
is
yeah.
so surprising.
Yeah. Yeah.
Yeah. So, um, you know, the fermented foods, it kind of goes similar to the conversation we were having about earlier about short chain fatty acids and fiber. Like it's all about protecting the microbiome. And fermented foods, they have bacteria in them. Something really interesting that's emerging though in the literature is like it's kind of a question of whether it's probably the bacteria in the food that are helpful in part, but it's also that a lot of these fermented foods, the bacteria in the food has actually already made some of those postbiotic chemicals even
Mm.
in the food. So when you're drinking kombucha, you're drinking the bacteria, but there's also going to be the chemicals. The bacteria in the drink have already done some fermentation, of the sugars and the starches in the drink, whether it's yogurt or kefir or kombucha. So there's going to be postbiotic chemicals that you can just directly absorb in that as well. So it's probably a blend of both the bacteria in the food and the chemicals they've created in the food that are helpful. And then you take something like a sauerkraut, which also has fiber, and then you've kind of got a triple whammy. You've got
Mm.
prebiotics as fiber, you've got probiotics with the actual bacteria, and you've got postbiotics with whatever they've created in that food. So it's really kind of like a triple hit. But there was a really interesting paper in, I believe, yeah, it was in Cell, and it was, Premier Medical Journal, and this was published in 2021. It was called Gut Microbiota Targeted Diets Modulate Human Immune Status. And they were basically looking at how fermented foods change the markers of inflammation in the body. And something that was really pretty crazy about this study is that they actually showed that, yes, the consumption of probiotic rich foods has a distinct impact on the inflammatory profile of the body, but it was people who ate around 6 servings of
Mm.
fermented food per day that had that maximal impact. That's a lot of fermented food. So a lot of people, I think, are like, "Oh, I eat fermented foods. I put a little bit of sauerkraut on top of my salad, like as a little touch." And what this paper said to me was, "Oh God, I think we actually need to be eating like fermented foods 2 different types in like every meal we eat."
Mm.
And that can seem really overwhelming. But if you think about it, it's possible. Like you could have some like a half a cup of unsweetened non-dairy yogurt for breakfast and, maybe a tiny little side of greens with some sauerkraut on top.
Mm.
Um for lunch, of course, it could be a soup or a salad or something with a sauerkraut or a kimchi. Maybe you do cauliflower fried rice with kimchi on it. And a kombucha, a low sugar kombucha. And then for dinner, add 2 others. Like, but when you think about the options between natto, miso, kefir, kvass, kombucha, yogurt, sauerkraut, kimchi. I may have said some of those twice. The other cool thing is you can ferment basically any vegetable. You can even ferment fruit. Like you can ferment asparagus, cabbage, beets, zucchini, onions, really anything. So I think learning how to actually ferment is really such a powerful thing. It's a lot cheaper too, but like you can just basically go to the farmer's market, buy whatever looks good, put it in jars, you put salt and water, you let it sit for several days. You have to release the gas, but naturally the bacteria on the food is going to interact with like the salt and water and essentially, is going to ferment. And so it's a real shift though, I think, to realize like that we should probably be eating a lot more than we think. So I keep a list handy of all the
Mm.
different fermented food options just to spark my brain. And similar to what I said about the fiber, I load my fridge with it. I always have 5 different types of fermented vegetables from the farmer's market or ones that I've made. I always have yogurt. I always have kvass. I always have miso in the fridge so that when I'm making a salad dressing, I put 3 tablespoons of miso in it.
Mm.
You know, I've started making my chia pudding with yogurt instead of coconut milk, which is a slightly different flavor, but I know I'm getting more bacteria. So it's just kind of a reframe. But I think it's the evidence shows it's really valuable to eat fermented foods. And we probably need more than we think.
I
So
know I know I need more. That's for sure.
yeah.
Okay, well that was man, nicely done. You say to minimize sugar.
Hmm.
I think most of us know that, most Americans get, what is it? I think the average is 30 added teaspoons of sugar a day in some form or another. And I think most Americans know it's bad, but dive in the way only you can about why it's bad for metabolic health.
Yeah, I mean, this is so the molecule of sugar in and of itself is not necessarily a problem for our cellular biology. It's the quantity of refined, ultra processed grains and sugars that we're eating. Because a refined ultra processed grain basically is sugar. And it's essentially a whole food that has been stripped of the fiber and the protein, and you're just getting that sort of straight carbohydrate, which is essentially sugar. And so there's all these different statistics that you will find about how much more sugar we're eating than we were 100, 200 years ago. But by some accounts, some studies are showing that we eat 152 pounds of sugar per year now. I mean,
Mm-hmm.
that is unbelievable. And this is not fruit sugar. This is not whole grains. This is high fructose corn syrup. This is ultra refined white cane sugar. This is what Americans are eating. It's like fruit is not the problem. The issue is with what it does to our metabolic health is that if you task any machine with all of a sudden having to do 50, 100 times more work than it's meant to do, like it's going to have dysfunction.
Mm.
Every single one of those molecules you put in the body is going to have to be processed by the body. So it's like we're tasking the mitochondria and the cells with just far, far, far too much work. And every time we do, the sort of molecular conversion of these things, it produces metabolic byproducts like reactive oxygen species and other things. And like the body just doesn't know what to do with all of this. So what happens is if the mitochondria essentially it's seeing like drastically more sugar in the diet, what's it going to do? Well, it's going to try and convert as much of it as it can. It's going to get overwhelmed. It's going to be producing a lot of this oxidative stress and free radicals. It's going to start to get damaged. It's going to get overwhelmed. And it's going to, instead of converting that food to ATP, to cellular energy, it's going to have to store some of it. It's going to have to basically shunt it to a different pathway, which is essentially printing fat inside the cells. And Cyrus talks about this, like the intracellular fat, the diacylglycerides and the ceramides and things like this. It's like, when you can't process all of the substrate, you're going to turn into something else. And so we're loading our cells with basically the conversion of sugar to fat. We're just overwhelming the machinery essentially. And one of the analogies I like to say is that, like, imagine that you had, because I get the question a lot, well, if we're giving the body more of this food, why aren't we just making more energy? And it's like if you had a cheese factory, and let's say that cheese factory is used to making a certain, they get milk and they make cheese. And let's say and it's working great. And you get an exact right amount of milk for the capacity of the machines, and you make a certain number of cheese and everything's going great. All of a sudden, let's say 50 times, 50 more trucks of milk deliver on one morning. And what would happen? The factory would not make 50 times more cheese. The factory would go into chaos. There would not be refrigeration space for the milk. The workers would be overwhelmed. The machines would be overwhelmed. And you would probably end up making less cheese because it's a shit show. And that's what's happening in the body. And the core message that I think is so important to realize is that part of what's happening is that these ultra refined forms of food, they don't trigger our body's normal satiety mechanisms. So our body's exquisite at essentially limiting our food to intake if it's getting whole foods and it's getting what it needs. And that's why if you have a whole foods plant-based person or a carnivore, both of them are not going to overeat. And the reason is because our body is exquisite at self-regulation. That system breaks down when you ultra processed foods. And so the issue is with chronic overnutrition and the overwhelming of our cells with these sugars and refined grains is that they're not food that the body knows what to do with. And so we overeat and we have chronic overnutrition and we totally gum up the system. So I tell people who are just getting started, like, do not worry about dietary dogma. Do not worry about any of the noise out there on social media. If you can do one thing, it is just start by eating real food, like unprocessed whole food. And I think what people often find is that if you can kind of force yourself to do that, you end up learning how to self-regulate. And that self-regulation translates to our cellular biology because you're not overwhelming the cells with too much substrate, which ultimately kind of breaks them.
Hmm. So this is, I mean, you, wow, do you ever know your stuff? I'd prefer, this is incredible. I want to move to another topic right now. Just so people know, the remainder of your 9 is basically focus on food timing, or eat organic, which we've talked about
Yeah.
a little bit already. And then also to combine food optimally, which we can, let's say that for another time.
Yep.
But I'd like to move on to exercise. And
Yeah.
what's your one takeaway for people regarding exercise?
Ooh. Well, I'll give a controversial take because
Okay.
I feel like people, I know you've had a lot of people on talking about exercise, but my biggest take, and I just finished writing my first book and it's coming out next May,
Ooh,
but
congrats.
thank you. So fun.
Does it
But
have a title? Does it have a title?
yeah, it's called Good Energy.
Oh,
And it's all about how we make cellular energy in the body. And so it's really a metabolic framework for health and disease. But obviously read thousands of papers about like food and exercise. And I'm like, the biggest takeaway I have about exercise is that I think the concept of exercise is actually hurting us. And I know that sounds controversial, but
no, bring it.
the reason is, of course, exercise is good for the body and we want to exercise, but we have very much created this framework where we think that if we exercise, which essentially in the mind is for a short period of the day, we check this box off and we do this thing. And therefore, the box is checked and we're done. That has created a culture where we think that, okay, the rest of the day doesn't really matter. And the truth is that our bodies are meant to move in sort of lightweight, low grade ways all throughout the day. And it's more of that building movement, just movement into the day throughout the entire day that is, I think, most powerful
Hmm.
for longevity. That does not mean we should not, quote unquote, exercise, resistance training, high intensity interval training, play sports. But the idea that doing it for an hour or two a day is what the body needs to be optimally healthy is wrong. We need to be moving throughout the day. And there's been New York Times articles saying like, sitting is the new smoking. Like this is not totally new information. And that, you can't exercise a sedentary lifestyle. And those things are coming to the forefront. But what I really saw was that from a cellular level, why this makes sense is that when we move our muscles, even if it's literally just like standing up every half hour to walk around for 1 minute, that movement is a stimulus to the cell to do a lot of different things. It literally, that is energetic information that tells the cell, for instance, to move the GLUT4 channel, which is what brings glucose from the bloodstream into the cell, to move it from the inside of the cell to the cell membrane so that it can actually let glucose come in. So just moving muscles activates pathways, even if it's literally just walking to the bathroom, of bringing those channels to the membrane. So you think about a person who's maybe moving, they set an alarm every 30 minutes to get up and do 10 air squats or to walk around their house once or to like take the stairs in their apartment building down and up. 2 minutes. That person, if they're doing it every half hour or hour, their body
Hmm.
all day is essentially metabolically activated. It's primed, the genetic pathways, the receptors, all these things are like, it's a body in motion. It's creating that physiology all day because you're hitting it every little bit. Versus someone who, let's say, has an 8-hour a day desk job. Maybe they get up twice, once for a snack, once for the bathroom, or 3 times the whole day. Otherwise, they're sitting. And then at night, they exercise for 30 minutes. They're not going to have stimulated that biology all day. They will be stimulated when they exercise, but like it's a totally different milieu in the body.
Hmm.
So there's this term that's been created called NEAT, which is non-exercise activity thermogenesis, which is essentially this like funny acronym for essentially just like moving more throughout the day. It's like, how do you in non-exercise forms move your body? Like oh, you park farther away from the grocery store and you walk more, you take the stairs instead of taking the elevator, you fidget your leg while you're at your desk, you use a standing desk, you garden, you're standing in the kitchen. It's basically like movement thermogenesis in the absence of true exercise. And the studies basically show that people who do more NEAT are much healthier. There's also studies that show that if you're getting above about 8,000 steps per day compared to someone who gets less than 4,000 steps per day, which is the average American is getting less than 4,000 steps a day, that you get above 8,000, you start slashing your risk for heart disease, stroke, dementia, depression, obesity by like 40 to 60%. And it's not the steps. It's a proxy for how much you're just moving throughout the day. And one really interesting fact that I came to in my book was the US, similar to the healthcare, the more we spend on fitness memberships and the more gyms per capita in the United States that exist, the fatter we are getting. Isn't that interesting? The more we're spending on fitness programming, the more unhealthy that we're getting. So it's similar to like the more we spend on healthcare. And I think part of it is a similar message. We're focusing on a little bit of the wrong issue, which is that we actually need to be thinking about how to build low-grade movement into our entire days, which is not what gets accomplished through a fitness membership or a gym or whatever it is. We need to be really thinking creatively as a culture about what it looks like to have a more day-to-day active lifestyle. Now, the reality is we're not going back in time to where like the majority of the population was working in agriculture and stuff, like we're on your feet all day. A lot of us are knowledge workers. A lot of us are at desk jobs. That's the reality. We can't go back. Maybe we could, but we're probably not going back to like an agrarian society. So then what does it look like now? Is it treadmill desks in schools? Is it, standing desks as a default for everyone? Is it that we just put parking lots, farther away from stores? Is it that we have more walkable neighborhoods? There's been data showing that if you have sidewalks in your neighborhood, you immediately drop your prediabetes and obesity risk just from the mere presence of them being there. Is it that we have new building construction standards that there need to be like staircases everywhere and the elevators are more hidden? I don't know, but we've got to be thinking a little bit differently because sitting bodies are the problem, and we need to be moving more throughout the day. So that's kind of one of the things. So how that looks in my own life. I mean, I'm sitting right now, unfortunately, but this is a standing desk and I have a treadmill desk actually directly across from me that I use all the time. But it's just thinking in all those little ways. How do I, as I'm at the computer, how do I move? Set my alarm to do 10 air squats. I keep a kettlebell right next to me at my desk. If I'm catching up with a friend or scheduling a meeting, I always try and do a hiking meeting or a walking meeting, those types of things. So just thinking creatively about it.
Terrific. Oh, great stuff. And so much of it is, Dan Buettner and all his work with the blue zones, right? But it's like, you just want to make it part of your day and like they do, ideally. Let's finish with this, and then I want to make a proposition to you. So we got a lot of men and a lot of women that are listening right now, and I'd love for you to talk about sexual health and how that relates to metabolic health. All right, go.
Oh, I love this topic. Oh my gosh, it's just so fascinating. Well, I'd say highest level, metabolic health, our blood sugar levels, our insulin levels, they're basically deterministic of both our state of fertility and our sexual health. So more like the sexual pleasure, arousal side of things. Two different things, right? Both related to kind of our sexual organs, but fertility and then sexual health and sexual pleasure and arousal, both are totally related to our level of metabolism. And of course, first principles, of course, if our cells in these parts of the body aren't working properly, we're going to have issues, whether it's the blood vessels of the penis or the ovarian theca cells or the blood vessels that bring blood flow to the vulva and the clitoris. Like all these things are cells that need to function properly. So let's just briefly touch on I think it's interesting to talk about fertility briefly. So we're in a fertility crisis in the United States. I don't know why it's not front page news every day, but
What does that mean exactly, a fertility crisis?
well, infertility rates are just going up basically every year. Rates of miscarriages are going up, rates of inability to conceive, placental dysfunction. Um, all of these things are increasing. Reports suggest that sperm count is down 50% in the
Mm,
average American since 1970. And PCOS, polycystic ovarian syndrome, which is the leading cause of infertility in women worldwide, is going up every year. And it's estimated to be somewhere between 12 and 26% of women in the United States. So let's just take sperm count for a moment. So something really interesting about obesity, and especially fat around the midline, which is the visceral fat, which is really the metabolically unhealthy fat. There's three different kinds of fat in the body. There's subcutaneous fat, which is the one that's like under our skin that we traditionally think of as sort of like fat, that we can see. Then there's visceral fat. And interestingly, subcutaneous fat, that's actually not associated with premature mortality. Like having a little bit of the fat under the
right.
skin is not really dangerous fat. There's visceral fat, which is the fat around our organs, the fat that like marbles us on the inside. Um, that is the very dangerous metabolic fat. And that's the fat that you can't necessarily see, but it often correlates with subcutaneous fat. And so that's kind of a key fat that we need to assess actually through lab testing and through scans like DEXA scans or other scans that look at the fat in our organs. And then there's intracellular fat, which is fat that's actually inside our cells, which we never ever
Mm,
want. And that's definitely fat we can't see, but a muscle cell filled with fat, a liver cell filled with fat, very, very bad. So in men who have more visceral adiposity, which is that metabolically unhealthy fat, that fat actually acts as a hormonally secreting organ that converts testosterone to estrogen.
mm,
And so and Dr. Ben Bickman from Utah, he's a metabolic researcher. He talks a lot about how like fat around a man's middle is basically like a giant ovary. So you're basically, it's an estrogen producing machine, and that is going to affect spermatogenesis. That's, you need this perfect balance of hormones to create sperm effectively. And if that's thrown off, there's going to be an issue with sperm production. The second way in men that this is related kind of overlaps with the arousal and sexual health angle, which is erectile dysfunction. And so an erection is just blood flow to the penis. It's tumescent tissue. You're filling the penis with blood. And, that's part of arousal, but also, of course, ejaculation, which is important for fertility. And so what's happening from the metabolic lens is that insulin resistance has
mhm.
a strong impact on our ability to dilate blood vessels because for multiple reasons. One is that insulin resistance in the brain actually perturbs the brain part of nitric oxide production. And then in the actual blood vessel walls that produce nitric oxide, which is the chemical in the blood that dilates blood vessels, insulin resistance blocks nitric oxide synthase from making this chemical that causes our blood vessels to relax. And then, of
Sure.
course, you take Viagra, which basically brings artificially through drugs more nitric oxide to the bloodstream and allows you to have an erection. Well, we could also fix that problem by improving our insulin resistance and freeing up our natural nitric oxide production capabilities. So, from a hormone standpoint and a blood flow standpoint, that is like metabolic dysfunction is directly impacting male sexual
Mm,
health. And then I'll just briefly mention on the female, and something wild is that like over the age of 45, like around half of men are dealing with issues with erectile dysfunction.
mm, mm,
And there's many doctors who say like erectile dysfunction is metabolic dysfunction until proven otherwise.
mm.
If you're having issues or that seems to be changing, you need a full cardiometabolic workup. And it's essentially one of the earliest signs for men before they drop dead from a heart attack or before they get Alzheimer's dementia that there's something going on with our ability to dilate blood vessels. It often goes hand in hand with high blood pressure and needs to be evaluated. So
Well,
that's
we like we like to say that the standard American diet is it's the erectile dysfunction starter kit.
That's correct. And I mean, this gets talked about in so many, I think this was even, they talk about this in Game Changers very poignantly.
Oh yes.
You remember there's that fascinating scene where they give the
Yeah.
men the 3 different burritos and like look at nighttime erections, and it's like it's pretty fascinating. So, yeah, so there's that. And then with women, so polycystic ovarian syndrome is a fascinating condition. Basically insulin resistance in female bodies leads to a state, well, in all bodies, where we have a state of hyperinsulinemia, high insulin levels. Because, of course, if the cells become filled with toxic fats because of mitochondrial dysfunction, the insulin signal doesn't work properly.
Mm.
That creates insulin resistance. The body says, oh my God, the cells are insulin resistant. They're insulin resistant. They're not taking up glucose as effectively. We need to produce more insulin to overcome this block that's actually caused by problems inside the cell. So the body spews out all this excess insulin and trying to drive glucose into these cells that are basically saying, we don't want any more glucose in these cells. We already have too much. And the body basically gets filled with insulin. That's hyperinsulinemia. Well, that insulin also stimulates every other cell in the body. And in the ovary, it stimulates the theca cells of the ovary to produce more testosterone and more androgens. And
Mm.
then that, of course, in women, because of it's a delicate balance in both men and women of what hormones you need at what levels. And that over androgen synthesis creates menstrual irregularity and many of the other symptoms of PCOS, like excess hair growth and acne and hirsutism and things like that. And so a lot of the interventions in the research literature to basically reverse PCOS naturally have to do with getting insulin resistance under control through diet. There's a really interesting study a couple years ago that was a 12-week intervention that was looking at a very plant-forward Mediterranean diet plus a polyphenol supplement. So it was a low-carb, plant-based Mediterranean diet with a polyphenol supplement. And the average participant in that study lost 22 pounds and reversed a lot of their insulin resistance, and their hormones became more regular in a PCOS population. So food-based interventions can really help with that. And they need to be focused on reversing the insulin resistance. So you take away that insulin signal, the theca cells, stop producing so many androgens, and you start, getting more normal hormones. So the way I kind of think about it, it's like in men, metabolic dysfunction is causing an imbalance of estrogen.
Yeah.
In women, metabolic dysfunction is creating an imbalance in testosterone, and both are leading us to basically have struggles with fertility. And then we talked about erectile dysfunction in men. Well, it's exactly the same for women. Arousal, lubrication,
Mm.
all of these things as a result of blood going to the sexual organs in women. You can't, it's not as obvious because, there's not a penis that's becoming erect, but those tissues are actually becoming erect in a female body as well. And tumescent, filled with blood. So if there are issues with dilation of small vessels in the female sexual organs because of insulin resistance leading to endothelial dysfunction and central nitric oxide reduced stimulation, you're going to have the exact same issue, which is essentially, less ability to become aroused. And it is actually devastating the rates of sexual dysfunction in women after the age of menopause. Close to 85% of women report sexual dysfunction, whether that's lack of sexual pleasure, lack of arousal, lack of lubrication. That is astonishing. And some of that has to do with the drop in estrogen after menopause for sure. But I think a lot of it, and what's compounding it, is that it's coupled with metabolic dysfunction in women, which goes up after menopause because estrogen is somewhat protective metabolically, that is basically making the issue worse.
Mm.
So it's bad because
It's
if you
pretty
start
messy, isn't it? Yeah.
messy, yeah, and this is a huge part of our life force, right? Our sexual energy, and metabolic dysfunction just like really puts some water on that flame. But it's
Hmm.
also, I think we really need to think about sexual dysfunction, infertility, erectile dysfunction, all these things as very much some of the earliest red flags to potentially future more life-threatening issues, and start seeing that link.
Mm.
Brief personal story, my mom unfortunately passed away 2 years ago from pancreatic cancer, which is one of the cancers that we know is super driven by poor blood sugar control and metabolic dysfunction. And when she was in her late 30s having kids, she had these early signs of metabolic dysfunction and insulin resistance. Like, I was born at 11 pounds, 9 ounces, which
Wow.
is almost definitionally shows that she had metabolic dysfunction. And the reason for this is above about 8.5 pounds, a baby bigger than that is considered fetal macrosomic, meaning like fetal macrosomia means big bodied baby. Like, if you translate that, macrosomia, big body. And kids who are born that are fetal macrosomic, which I was like squarely in that category at 11 pounds, 9 ounces, go on to have higher rates of metabolic disease, obesity, diabetes, etc. It also is a signal that the mom may have had some issues with metabolic issues. Insulin is an anabolic hormone. It's a pro-storage hormone. It's a pro-growth hormone. That's why it's associated with, obesity and it can drive cancer growth. It's anabolic.
Yeah.
Well, it also grows big babies. And so I don't believe that insulin crosses the placenta, but the high glucose in a mother can cross the placenta and actually lead to insulin resistance in the fetus and drive. So something I think about, I haven't had children yet, but I want to in the next couple of years. But like, in terms of having an easier potential birth, one of the biggest motivators for me is like, if I can keep my insulin and glucose very, very low and not like just healthy, that is not only going to lead to better birth outcomes regardless, because we know that obesity and diabetes, it is associated with increased rates of things like placental dysfunction and miscarriage and more difficult birth outcomes. But it also like it could impact the size of the baby. And I think there kind of was this funny thing in our culture where we like sort of celebrated big babies. Like, I was celebrated as a big baby,
Yeah.
but we actually want a healthy size baby, which bigger is not necessarily better. So anyways, with my mom, I look back and, she had this, which is a clear sign that there was something going on in her body. Then she, of course, in her 50s went on to get high blood pressure, and then she got the high cholesterol, and then she got the prediabetes, and then she got the gaining weight around the midline. And then all of a sudden she, dropped out of pancreatic cancer. And everyone's like, all her Stanford doctors are like, this is so unlucky. This is so, oh my gosh. Like, it was, between her diagnosis and her death, it was only 13 days. It was very fast. And everyone's like, oh, this is just so shocking. It's so unlucky. And it's like, it's not shocking and it's not unlucky. There were signs for 40 years that this physiology was going on, that was going to lead to a huge problem. And of course, she was shuttled to all the different specialists. She was on all the different medications. And I think this is happening in so many American families where there's all these different things going on and we're playing whack-a-mole in all the different subspecialist office. And what if we could really, if we did have a more holistic root cause metabolic lens, we could really help people understand how these things like fertility and then future disease are related and empower people to get on top of it. But if the OBGYN isn't mentioning it and the primary care doctor's not mentioning it and no one's mentioning it, of course, it's going to be harder to create change. So I just wish if I could go back in time and we had a different system that her OBGYN could have said to her, this is really not healthy that you had a baby this big. I want to do a bunch of metabolic tests in you. I want to check your fasting insulin. I want to check your triglyceride to HDL ratio. I really want to figure out what's going on inside your body, Gail, my mom. And if things come back poorly, we're going to really need to focus like full court press on diet and lifestyle to get your physiology under better control. How different the next 40 years could have been. And so that's really one of the things that really motivates me.
Yeah, no, you said it there. We really need, literally and figuratively, we need to get on top of it.
Yeah.
as we wrap up the sex chapter here.
Yeah.
Let me ask you one more question before we close out, and that is, do you right now have a favorite food?
Whew. Oh my gosh, that is such a great question. The first thing that came to mind was Ella's Flats, which are a cracker made all of organic nuts and seeds. They're really high fiber and they feel like a no compromise way to have a really good cracker that's like low carb, like, doesn't not has a bunch of refined grains in it, really delicious, lots of great nuts and seeds. So that's one of my favorite things, Ella's flats. And I dip it and I make a beet hummus. And so I have my cute little Ella's flats with some beet hummus on top, and I love it. How about you?
Yeah, it would definitely. Well, right now it's the Keef mango. It's this Keef. It's called the Keef Kong, and it's like the most incredible mango. And each one is like 1.5 pounds or 2 pounds.
What?
Oh yeah, it's fantastic. And
Oh,
I
I
eat it with my hands.
Oh yeah, you got to get in there. I was just in Kauai for 2 weeks, which was very lucky, and I have to change my answer because there was a passion fruit lilikoi plant and a star fruit tree in the yard, and I have not eaten those before, and I was just like, oh my God, blown away. Flavors like nothing else. And soursop as well. So tropical fruit, I feel like would also be high on my list right now. There's so much good stuff out there.
I've been to Kauai before. I've hiked the Nepali Trail and eaten the passion fruit along the way. It is remarkable.
It's unreal.
Nice. So here's my proposition for you. I feel like we've done a pretty good job making a dent into how just insanely knowledgeable you are on all this metabolic health. And, I love the fact that you have a book coming out in May called Good Energy. Wow. That's a really catchy, beautiful title for a book. Congrats on that.
Thank you.
But I really want to dive more into insulin resistance, insulin sensitivity. I know you're a fan of the continuous glucose monitor. You're the co-founder of Levels, and you guys have one. But I don't feel like I know enough. And so I'd love to have a 3-way conversation between myself, yourself, and somebody like Cyrus Khambatta with Mastering Diabetes. So if you're game, let's schedule that for a part 2 of this podcast. And I think it'd be a riveting conversation. I think everybody would get a lot out of it.
I would love that. I love Cyrus Khambatta's work. I think I have his book right here behind me. And he's been a huge influence on me. So that would be really fun to talk about that. And of course, he's super well versed in continuous glucose monitors, given his work and his type 1 diabetes. And so it'd be fascinating to talk about that. Yeah, would be
great.
Happy to. Yeah.
Well, listen, Casey, I am so glad that we got to spend some time together this morning, and appreciate your work, everything that you're doing. So glad that you got out of the ear, nose, and throat and into metabolic health and what you're doing. So thank you for making the world a better, healthier place. And can you give me a little Plant Strong fist bump on the way out?
Boom.
Boom. All right.
Thank you.
We'll see you shortly. Okay.
Okay.
All right. As you heard there at the end, I'm going to have Dr. Means back on the podcast so we can dig a little deeper on insulin, glucose, blood sugar, and the rise of continuous glucose monitors. Until then, as Dr. Means says, eat real whole foods, and as I like to say, always keep it Plant Strong. We'll see you next week. Thank you for listening to the Plant Strong podcast. You can support the show by taking a quick minute to follow us wherever you listen to your favorite podcasts. Leaving us a positive review and sharing the show with your network is another great way to help us reach as many people as possible with the exciting news about plants. Thank you in advance for your support. It means everything. The Plant Strong podcast team includes Carrie Barrett, Lori Kordowich, Amy Mackey, Patrick Gavin, and Wade Clark. This season is dedicated to all of those courageous truth seekers who weren't afraid to look through the lens with clear vision and hold firm to a higher truth. Most notably, my parents, Dr. Caldwell B. Esselstyn Jr. and Ann Cryle Esselstyn. Thanks for listening.